Okay, so here we want to discuss even and odd function. A function is even if when we put negative x into it, we get the same value as putting x into it. So these y values are the same for x and negative x. It's odd if the negative can somehow come out of this. So I have f of negative x is negative f of x for all x in f's domain. So for even functions, right, what we can have, for example, f of x equals 3x squared is even, right? Because 3 times negative x squared is the same as 3x squared, right? Because the even power, negative 1 squared is positive 1, and so that's what's going on there, right? I could have, g of x is maybe 2 plus x to the fourth. Again, if I only have an even power of x here, if I negate x, I get the same answer, right? Some other ones, for instance, the cosine of theta is even, which means that the cosine of negative theta is the same as cosine of theta. Okay? Now, these even functions have symmetry about the y-axis. If I look at, y equals 3x squared, or even just y equals x squared, so here's y equals x squared here, I can see that whether here, for instance, at 1, or over here at negative 1, I have the same height. So if I could crease this paper along the y-axis and fold it over, the two sides would match. Okay, so that's the symmetry involved here. Now for odd functions, so for odd ones, we can have, h of x is, x cubed minus 5x, right? So h of negative x is negative x cubed minus 5 times negative x. So this is negative x cubed, and I have plus 5x. So this is negative of x cubed minus 5x. So this is negative h of x. So I can go through and I can show this is odd just by that. Notice I have odd powers here. And in general, if all I have are odd powers in a sum like this, it's going to be odd. And odd functions are symmetric through the origin. So for example, if I have, say, y equals x cubed, so here's y equals x cubed, which is an odd function, and basically it's symmetric through the origin. So here, if I take this point here, and I go through the origin here, I have another point right on the other side. So we have symmetry about the origin. Okay, I don't know why I wrote that in red. It's kind of ugly. Anyways, most functions are not going to be even or odd. If I want to show a function isn't even or odd, so what I'm saying is that, for example, let's say f of x is a 1 plus x cubed. Okay? And I claim that this is neither even nor odd. And all I have to do is find points that don't work, right? So my f of negative 1 is 1 plus negative 1 cubed. It's 1 minus 1 is 0. F of positive 1 is just 2. So f of negative 1 isn't the same as f of 1, right? And this implies that f is not even, but also my f of negative 1 is not negative of f of 1, right? Because my f of negative 1 was 0, negative f of 1 was negative 2. And this means f is not odd. And I probably could have also seen this by the symmetry, that where it's going to lack the type of symmetry that we want.